All right, I think we're ready. We're going. Yes. All right. Last time we kind of finished up. I don't know if finished, but we got our clipper installation up and running. There's probably still more we can do to that. I did think of one thing. We had the issue when we installed the board, not to do with clipper, but the actual SKR board. Since we're not using the Z-axis probe, I do have one of the little plugs that we could, I guess we could splice this into the cables that we had to just put into the combination with the input power. So we had our fan, the heatsink fan that didn't have didn't have plugs on the end of it. It only was in a terminal block in the previous board. So we could use this as one of the ways to solve that problem. Currently, it's still solved with we just twisted the wires together with the power coming in, and it works for now, but I don't trust that super long term. But we got Clipper running. We did a little bit of the tuning. We did PID tunes. We did a E-step, rotation distance tuning, equivalent to E-steps. So I don't think we printed. I just extruded. Oh, I remember the last thing we were doing is we were going to do a bed mesh, and we went to home the machine, and it crashed because there was a block of filament from all the E-step or the rotation distance tuning. It was stuck on the nozzle, and so the nozzle couldn't actually home. And so that's where we ended. I don't know if we'll do any of that today or not. I did finally get the Timeplast. Finally, it wasn't that long, maybe less than a week, probably. Maybe it was more than a week. In the week time frame, the Timeplast filament came in. So I have 4 rolls. I think we'll try printing with one of them today. And let's look at those. So, you can kind of see. So this is not Timeplast. This is, I think I've shown this one before. I don't know that, but I think I have. This one is a conductive filament from Protopasta. So it has, I'm not sure what's actually in it, but it does have a conductive material inside the filament. So, for instance, if we were to take our multimeter and measure resistance, it should have some electrical resistance. Let's put that the right way up. So let's just say we want to measure from here. Oh, here we are. Where are we at? There we are. Here to somewhere down the line. Maybe here. We get, what's that, 4 kilo ohms. So it's not like super conductive. That is 4,000 ohms right there. And if we put it somewhere in the middle, so maybe like right there, we should be in 2,000 ohms. Yeah, 2,200. So maybe it was more like that. So it is electrically conductive. So you can print traces, not like you would on a regular circuit board. It's not nearly as conductive as something copper or any kind of actual metal, but it is conductive. It has probably carbon fiber or graphene or something. I don't know what's in it, but something conductive is in there. And I assume we would need a hardened nozzle because it does have some kind of included material stuff. So probably a hardened nozzle, but we have a 0.8 millimeter hardened nozzle on our Ender 3 now. So if we wanted to, we could print something conductive. This is really good. We use this, not really good, but it works. We use this to print strain gauges on other printed parts in a previous year. And it works really well when you have a way to flip filaments. Maybe you've got a tool changer, or you've got AMS, or you manually, pause and change out the filament. That's what we did. But if you have a non-conductive filament in one slot and the conductive filament in another slot, you can actually print embedded conductive traces that you can do things with. And we actually were able to get some form of a strain gauge printed into a product. So maybe we'll try that again on the bamboo, since it can more easily flip between 2 different filaments versus having to manually swap. Maybe we'll try that before the quarter is over. we're getting pretty close to the end of this sequence. I did have one request for, it was particularly for annealing parts, and more generally for strengthening parts. And so we'll talk through that. Annealing is where you print your part and then you heat treat it, maybe in a toaster oven, something. You don't obviously can't get it too hot because it still is plastic, but you can basically create a stronger, tougher part by annealing it. Now, the problem with annealing plastic is that it's, plastic is going to have more deformation at much lower temperatures than something you would normally anneal, like a metal. But you can do it, and there's some better and worse ways. I don't know if we'll be able to actually anneal something, but we can try. That does remind me, I haven't looked at it lately. I'm looking up the filament dryer the next one that I want that is capable of annealing. All right, I think we're back. I don't know why we had our early morning disconnect there, but I assume somebody, Sunlu in this case, releases one of these that can go up. It says on the picture here 110 Celsius. It says it in the description also. So we could anneal at that temperature. You don't really want to anneal in basically your oven or something like that. For one thing, most ovens outside of like toaster ovens they actually have trouble getting that cold. They want to be much higher than that. So it looks like Sunlu so far is the leader forefront on the dryer boxes that can actually anneal. But Creality is going to have theirs, and I don't know if Bamboo will have one or not. They don't seem to do too much with that, although their new AMS does have some drying properties in it. So looks like right now they're still kind of expensive, and they are, maybe they're good. I haven't tried it. Got a 3-star and a couple of 5-star ratings, so some people have tried. I think if I were going to go into annealing currently, like that's part of my workflow, I would probably just get a toaster oven, and that's going to be way cheaper. Going to have similar-ish heat controls, and that's probably what I'd do. All right, so enough of that. That's not the Timeplast filament. So I did go. Here's the Timeplast website. I noticed that they have a subscription here where you can $20 a month. You get a new sample, but it never told me how much the sample was, like the quantity. It shows one of these rolls, which are probably half-kilogram rolls. I have some of them over here, but it doesn't actually say that's what you get. So I don't know. It could be like you get a couple of meters. I don't know. So I did not sign up for the subscription, but if I can find out that they give you a whole roll every month, then I might do that, because they have a lot of interesting things. So they've got all sorts of filaments. Basically, their business model is not specifically to filament. That's just what they seem to be doing most right now. But they have all sorts of other products. But they have very degradable filament, plastic in general, and they've currently turned it into filament. And there's all sorts of things. I picked 4 of them. They're all different kind of prices. Some of them are way more expensive than others. These are all 1/2, so 500 gram rolls, I think. Does it even say on the things? It does not say, but I'm going to guess. Do I have a scale? I don't have a scale handy to weigh them with, but I'm going to guess they're half-kilogram rolls. They're not. I don't think they're full kilograms. Let's see. I don't know. I don't think they are. Maybe they are, but I don't think so. The ones I picked out are over here. So I did the soap. Now all of these say, and the box you get it in says, that their filaments are meant to be dried before you print them. So you have to have some way to dry them. I have I think a Elegoo is the one that I have for a filament dryer. So I did dry this one 6 hours at 50 degrees Celsius. It didn't actually, I never saw anyway, drying profiles, dry at this temperature for this amount of time. I didn't see that. It just said that they all had to be dried, that they intentionally were kept not dry, I guess humid or whatever, full of moisture, so that they didn't become brittle. And they all feel like TPU. So they all have a feeling like TPU. They're a little bit rubbery. Even now, this one might supposed to be rubbery. No, that's the fire one. So they all feel like that. And I guess I could feel that the soap is slightly less rubbery now that I've dried it. But it does say that before you print them, they don't seal them in vacuum packs or anything. They're actually trying. One of their company missions is to eliminate plastic waste, so they don't give you any plastic waste, and their filament is set up to be degradable as far as I can tell. Some of it is like it dissolves overnight in water, kind of degradable. So I have dried this one. It supposedly is soap. So if we look at the page here, let's see, where's the soap one? I think it's this one. So $24, and I think that's a half kilogram. Let me get a scale. I have one over here. So let's just see. Whoa, banging you around. So there's our scale. You actually can't read the numbers on it. I don't know if I can get it angled in a way that you can. So this is with the spool and everything though. And I know it's not picking up, but it says, oh, that's pounds. Hold on. Let me get it in kilograms. All right, there's kilograms. Let me see if I can orient it any way where you can actually, oh, wait, maybe. There you go, you can read that. All right, so 0. Yeah, half kilogram. So they are half kilogram spools. And so this one was $25. That puts it in the $50 range per kilogram, which is high for a filament. It's not high for specialty filament though. So if you think of it as specialty filament, then this is in par with most other specialty stuff. So it says that this has vinegar, borax, zinc oxide, I don't know that one. Miconazole. I don't know what that is. Nitrate. Only 2% of that. And I think that, the borax, I guess, is what gives it kind of a gritty feel. And so they're using vinegar as the natural disinfectant, and then that nitrate as the fungus fighting hero. So we'll try to print this one today. Actually, all the ones I've looked at give you a how to print section here. I did try this out. They do have a GPT that's like a SME, like a subject matter expert on their filaments. So it's sort of a custom built GPT. And it seemed to work okay. I did not try, I haven't printed with it yet, but the stuff it fed me was basically this. But you could ask it things like, I have this printer, I want to print this filament, what settings should I change if I use this slicer? And it would tell you, although it gave me some settings that I've never seen before, so I don't know if I just haven't dug into the slicer deep enough to see those settings, or if it kind of hallucinated some settings that you have to infer what that actually meant. Anyway, they all give you just a list of stuff here. Actually, looks like Bamboo has a profile. So I want to print this on our ender though, right here, so we can see it. I will try printing it on the Bamboo later, just you can't see what's going on there really, so we'll do that. Oh, actually, no, I read, so the Bamboo I'm talking about has an AMS on it, and since these are rubbery filaments, like they're like TPU, the AMS does not work well with TPU, so I'd have to side load it anyway, which maybe I'll do that, but we'll try printing it here where we can see what's going on first. The only thing that I noticed were that it was printing hotter, so it's in the upper ranges of what you would normally print on a Ender 3. The bed temperature was a little hot, maybe in the PETG range. This was the main difference, was that it did not like cooling. So no cooling at all for the first, in this case, 3 layers. That's pretty normal. But then the maximum cooling was only 15%. So now these actually, 0% for the first 100 seconds, 15% started at 8 seconds, so that doesn't make much sense. But I think what they're saying is that the 15% is for overhangs and bridging. If you have, I'll just make some part that doesn't need overhangs or bridging. So we will probably leave the fan off. So I think that's the deal there, is that this one, and it seemed like a lot of the Timeplast filaments did not like cooling in general. And yeah, there's the 15% is only for complex geometry, overhangs, bridging, maybe some fine details, something like that. It gives you some maximum volumetric speed. That's kind of in the maximum for Ender 3 anyway, so that's kind of normal. Gave you some retraction distance. Now this is going to depend on your direct drive versus Bowden system, but this is similar to what we already have, although this is much slower retraction speed than what we have in there. So we might need to drop our retraction speed down some. Pressure advance, that's only if we're running Clipper, which I guess we are on this printer, so we will need to check and make sure that pressure advance is set to a relatively low number, which I actually think it is right now. It looks like we're doing a 92% flow ratio, so we're probably not doing that currently, so we'll have to work on that. And then these are some of the settings that you might have a difficult time finding in your slicer. Arc fitting, that's so we haven't talked about this. So when you make circles and arcs in G code, there's 2 ways to do it. One way is a whole bunch of line segments, like tiny little straight lines that you put them all together and they're small enough it looks like a curved line. That's what your slicers do by default. Some slicers in firmware and even post processors can interpret those as curves, like actual arcs. If you can do that, then that saves a lot of individual tiny little movements and it makes it one smoother movement. So that's not always an option. Depends on what your printer and slicer and post processing is, if you can do this or not, but that's what they're talking about here. Gap closing radius, I've never seen a slicer setting called that, but it looks like it's basically what's the smallest gap you will allow in between walls and between the walls and infill, stuff like that. Elephant foot compensation, a lot of times this is called first layer horizontal expansion, and so it's to you're trying to squish that first layer down, but that makes it wider than it's supposed to be, so you programmatically shrink it so that when like the size of it, so that when you do squish it, it comes out roughly the right size. There's just standard settings, 2 walls, turn on detect thin walls. That would depend more on your geometry though. 3 top bottom layers, that just is telling you the the thickness is not necessarily dependent on the layer thickness though for the top and bottom. Monotonic pattern, you can have different patterns for the top and bottom layers. So there's a lot of these settings. Most of them are stuff you're already doing. So there's a couple of them that you'll probably have to change, like the cooling fan is mostly off, and then maybe the flow rate might need to change that. Most of these others are going to be kind of default settings anyway. So we'll see in a minute if we can get this to print. All right, the other ones we got were, we have this one, the Fire Gen. The idea with this one is that it is combustible. It's I, I put this these four into not the Timeplast GPT, but a different one, and told it to summarize them, and it thought this one was fireproof or fire resistant, but no, this is the opposite of that. This one is meant to make like candles and things that burn. So not sure what that one's going to be like, but that's what it does. Let's look at it on the page over here. Fire Gen 2. They're constantly updating these, so like the soap is Gen 4. Let's see if I don't think these are in any particular order. So there it is. So yeah, it's meant to be like a combustible printable thing. So I don't know. Let's see. Here's some ideas. Lanterns, flame trees, fire flowers. I don't know how fast it burns or whatever, but I don't know. It even says it has customizable burn rates, probably by the thickness of the lines that you're putting down. A lot of these did say that you could add scents, like essential oils. You could add as it prints, and it kind of distributes through the model. Like you pause it, put some oil, essential oil in there, and it distributes throughout the model. Don't know. I might have some somewhere over here that we could try that with, but we just are going to try to get it to print first. So we got that one. I did not dry that one, so it's not ready to go. We have the ball. I don't know if you've seen the airless basketball. A lot of people on YouTube have tried printing the airless basketballs with different materials. The original ones were printed on the really big SLS. I think they were SLS. Maybe they were SLA. I don't know. But the big printers. But people have printed them on things like the bigger FDM printers. But they usually don't bounce very well. So they have, you know, if they bounce, they kind of bounce, or they're very not like a basketball. This one is supposed to be the solution to that. So I don't know. It would take a long time to print one of those. And it might take this whole roll. Actually, I don't even know if this roll would do the full-size ball, but maybe we could do a baseball or something. I don't know. Let's see if we can find it on here. Let's see. I mean, they've got baby gender reveal. They've got all kinds of stuff in here. I like this. There's a bug attractor one, and then there's a bug killer one. So I don't know. Put those two together. Where's ball? There he is. So let's see. Now the other uses for this one are like vibration dampening. That might be interesting in an engineering setup. Flexible grips and soft touch surfaces, stuff like that. Robotic actuators might be pretty interesting. It feels a lot like TPU. Most of them feel similar. This one feels a lot like TPU, but these are not your typical plastics. So I don't know if it tells me what's in here. Not in there, I didn't see. Do not ingest it, so okay. Same types of print settings. Very similar. Actually, those might be almost identical to the ones that we looked at. So this is more of their propaganda. Well, propaganda is maybe a negative word. Their advertising. All right, so I got that one. And the last one I got was the fish bait one. So the idea with this one is that you can print fishing lures. There's a fish food one, like for a fish tank, but this is the fish bait. I don't know how they're different. They're different colors. Let's see. Here it is. So it does say this one is water soluble. So I guess if you lose, it says that it's built to dissolve after 1 hour in water. So you're not going to fish with this particular lure if you print something with this for more than an hour, because apparently it's going to dissolve. It has worm, shrimp, squid, and fish meal in the filament. So it doesn't stink, but it does smell different from the other filaments, and I assume it's because it's got all this stuff in it. And then once you cast it, put it in the water, it activates, meaning that it starts to dissolve and it releases all of this worm, shrimp, grit, all this stuff. And so says it's a, and it starts softening the bait because it's releasing some of the stuff that's in it. And it will supposedly attract fish. I think I will try this one out. I have not dried it yet, so it's not ready to print yet, but you can usually find plenty of fishing lure models already made. Now, in most of the ones that you look for on the internet, they're hard, they're rigid models, like rattlers and things like that. So I don't know if we can find a flexible one or not, but I know that there is a different community that prints the molds for those, so we might can find molds for flexible worms and such. So, or maybe we'll just design our own and see what happens. So I got that one. Again, it's not ready to print, so we'll have to wait on that one. So let's get our printer going over here. Didn't plug it in, so it's not quite ready to go. And I don't know, let's just see if we can get it to print any of this stuff. So we'll have to, well, that's not interesting. Let's go over there. We'll have to let it boot up so that we can take our old filament out. This is pretty typical. The filament snapped right here. That is showing me a little bit that it's starting to absorb moisture. You know, we're in a very humid area, and I'm in the shop part of the house, so it's even less climate controlled. So this is not uncommon that this will happen. If it does, then, you know, just back your filament out, and usually you can take this and whenever, all right, so this part is still pliable. It just had enough strain on it right there to snap right there. If any of it just snaps off when you bend it, I would not bother printing with that part of it. I would just snap it off and print it somewhere else. Alright, so let's get that out of the way. And let's see. Sometimes these flexible things are hard to load. Probably going to be a pain to load that kink in there, so if I can find some cutters, we will cut that off just to make it easier to load. Don't really want to waste any of this, but maybe we'll see if this part dissolves. I'll go get some water while we're waiting. Alright, so we're going to have to get our old filament out. Let's see. Oh, we have our screen, clipper screen. We should be able to operate from there. Let's see, temperature, extruder. I don't know if you can see what I'm, there we go. And let's go for PLA and, oh, not, there we go. Didn't want the heater bed. Heater bed. I guess that's okay to call it heater bed, but that's what they did. So we can actually, now that we have the clipper screen going, we can actually do a lot of our work from here. We could even print from here if we loaded a thumb drive with files. I guess we could do that. Let's see what we're going to try and print, though. I wonder, I have not looked to see if there's a bar of soap. I bet there's the Fight Club bar of soap. Actually, no, there's just not many bars of soap already made on Thingiverse anyway. See if I can find anything. There's some molds for like what you would normally do if you were making a bar of soap. And most of these are soap dishes and soap trays, stuff like that. Let's do another. Oh, what do we got? Can you attach Legos to your? Yeah. So this particular one has a Lego compatible row of studs on it, and yes, you can connect things. I think one of the things you can do is a pie cam, that you can set up there, but it will connect whatever you want to. That's the housing. I didn't print it. This is a commercial housing. It's broken right here, so that should be a corner rounded off, but that part's broken. But yes, it's a Lego compatible for whatever you might want to attach to it. Let's see. If I can find something that is going to look more, I guess we could make our own soap. Here's one. Let's see. And yes, there's the Fight Club one. This one pretty ordinary. I don't want something super complicated. That one actually, let's do this one if I can find it. Oh wow, no, that one. Oh, here's a free one. That's this one. Oh no, that one's free. All right, so I'm on free3d.com, which apparently all of the things there are not free, or maybe these are ads on the left-hand side. I'll show you. So I haven't actually used free3d.com much, if any. But there's a bar of soap. I don't know if I like the amount of overhang it has. This is probably, let's see, what kind of format is this? It is an STL file and an OBJ file. So I was going to say it was probably meant for like rendering in a scene somewhere, a digital scene. And there's no way that it's going to pick up that tiny little inset there. It might pick up the letters. Let's download it and see. Let's see, is that that's a zip file. I don't like because I don't know Free3D. I don't like downloading zip files because it could be all sorts of things in there. Let's just make our own. Let's go to Thingiverse. No, not Thingiverse. That's not what I meant. What's it called? Tinkercad. Go to Tinkercad. Oh, I gotta log in. I think this one hopefully remembers me. Yes, because I don't remember it. Let's create a 3D design. Let's get it where you can see all of what I'm doing here. I think one of these basic shapes is more or less a bar of soap. Oh, I just noticed that I'm still down in the bottom corner. I guess that's fine. Let's see, which one of these looks most soap-like? This one will be sort of soap-like if we flatten it out. So let's do something like that. I mean, why don't we just do something really simple? Something like that. Let's see what dimensions these are. I don't want it to be too big because who knows if it's going to print very well or not. Let's make it 2, and let's make that by 1. Yeah, so it's not a very, actually let's do 1.5. Doesn't look right. That looks okay. And then let's put a put some writing across the top of it. Let's see, let's make it a hole, and let's write soap on it. And let's make it smaller so it's not so giant. And then we'll put it here. We don't want it to dig through the whole thing. There we go. One more notch down. Apparently that's fine. That'll be fine. It's all fine. Alright, so there's our soap. We'll test, you know, this is the little column with the O. That's pretty tall aspect ratio, so we'll see how well it can handle that. I don't know. Alright, so let's export that as a STL file. And then we'll go into Cura, change those settings it told us to change. So the names you get in Tinkercad, Frantic Crunk Trug is our name for this file. I assumed I saved it to the desktop. I don't know. So let's get Cura going. And let's go back to, I don't think we need the Bamboo Studio. Let's go back to our instructions on this. So let's go to find the soap one. Oh, what's microwave? Huh. So it's a 4D filament that somehow microwave waves affect it and deform it. Interesting. Not sure what you're going to do with that, but that's what it does. And it's super expensive compared to the others. Urn. Where's our soap? There we go. Oh, let's see what else is in there. How often do I... Oh, outside of class? Definitely multiple times a week. I wouldn't say daily, because there are days I don't print, but let's just say multiple times a week. On average, anyway. Let's see, how to print. Let's see. Alright, so we got to do 240, 75. Cura looks like it just opened. So, we've got the larger nozzle. I think that does affect one of the settings. Maybe the cooling setting. I'll have to look and see. I saw some of them that were nozzle dependent. Let's get our part in here. Our soap. Probably on the, I guess, desktop. Oh yeah, it was the Frantic something or another. Maybe it's downloads. There it is. Alright, there's our soap. We could have, see how it's faceted? We could have rounded it out in Tinkercad with more faces, but this will be fine. Or we could have gone the other way and made it more faceted if we wanted to. Alright, so it said temperature at 240, so let's get that changed. Actually, will it let me change? I wanted to create a custom filament here, but I don't remember how to do that. We'll do that later. Alright, so 240 and build plate 75. Okay, let's see what else we need. That's those. Oh, here it is. Okay, that's just telling me that. Oh, yeah, the cooling. So, cooling. Let's select. Oops. I meant to click this guy. All right. So we do want some cooling, but we want a maximum fan speed at 15%. So we're going to put that in there. Fan speeds normally 0. Let's see, what do we have? Initial fan speed. Let's put that in here. 0. Does it let me... Small cooling during extruder switch. I guess I have fan speed at a height. So... Oh, that's in a different setting. Let's... Build volume fan number, change the value. Okay, wow. Okay. Oh, that's the build. That's the chamber. That's not what we want. Let's just make our regular fan speed 0, and then maximum at 15. Initial is 0, and see if that does what we want. So minimum layer time, yes. Regular fan speed at layer. Oh, we could do that, I guess. So regular, although my regular is 0, they said layer 3 was, well, no, at 4, so after 3. So that's good. So that's actually what they had already. Okay. Volumetric speed, that'll just be a function of our nozzle diameter and how fast we ask it to print. Retraction distance, let's see where we're at on that. We'll have to search for that one. I think it lost focus. Enable retraction, we're at 0.5. It said 0.4, so we'll go to 0.4. This is a big one here, 15 millimeters per second. We're at 45, so let's actually change that way lower. Pressure advance, that's on the clipper side of things. We'll have to do that. That's not in Cura. Flow ratio at 92%. Let's look up flow. We're probably at 95 or 100. We're at 95. We'll go down to 92. Okay. These I can't do arc fitting in Cura as far as I know. That's more of a post-processing. I think Clipper can do it on the fly also. but I don't think Cura does that. Elephant foot compensation, that'll be horizontal expansion. Here, and it's the initial layer horizontal expansion. So it said 0.1 millimeters. Okay, we do that. Top and bottom is 3 with the, well, it doesn't know what layer size, 1.5 times the nozzle size for solid strength. So that's going to be really a lot for us. But let's do top and bottom, not on horizontal expansion. It said walls 2, top and bottom thickness. We have much more because of our layer height. We might want to reduce our layer height. It did say something in the write-up, not that I've seen here, but in the write-up about it, that cooling the internal mass is a problem and it wants to crack or warp. So we might want to reduce our layer height to something a little bit smaller than this, maybe 0.3. And then go back to 3. No, that's walls. 2 walls. 3 top and bottom layers. What does it say for infill? Oh yeah, it wanted the pattern to be monotonic. Can I do pattern here? That's the... let's see if I've got pattern over here. Skin layers, thickness, pattern. Let's turn on the pattern. These are options that you can, if you, in Cura anyway, if you click the little slider bar, oh, it's off your screen, hold up. Let's make it not go off your screen. If you click the little sliders here, it gives you all the options and you can check which ones you want to add. So I wanted to say the pattern was, and I don't have monotonic, so lines will be the closest to monotonic. Let's see. These are pretty standard. I don't even know if we have smooth coefficient. I don't know if we have that. Avoid crossing wall. That's in the might be in the top layer settings, or it might be in the retraction settings actually. Combing. Layer height 0.3. That's what we actually set it to. Initial layer height 0.35. All right. So let's go to our layer height one and see if we can do initial layer height. So a little layer height there, and make it 0.35. Seam, I'm not going to worry about that. Wall infill overlap. This is the amount that you have your interior wall overlap with the infill. You can tune this to actually have your infill do something, like connect to the walls, or you can pull it in so that it doesn't interfere with your outer surfaces too much. If you've been printing your benchy and you've noticed zigzag or kind of diagonal lines on, particularly on the cabin part of it, it's because the infill is showing through, it's pushing through, and you might need to change this overlap percentage. I don't know what we've got it set to right now. Let's see. Infill, so we actually have it at 30% and it wanted it at 10%, so we'll drop that down. Accelerations, I'm going to leave those more to the printer. These are probably in the range of what we have. Actually, these are kind of high for this printer. It's probably even less than this. There's our skirt so that we can get a test around our print. We don't need a prime tower because we're only printing one material. We're not switching. That's just talking about the start script if you were running Clipper. We'll look in our Clipper printer config and see what pressure advance is set to. Oh, here's finally. So I don't know. I dried at 6 hours for, or well, at 50 degrees Celsius for 6 hours. My dryer will not go to 100 degrees Celsius. So maybe we're not fully dry yet. It says, I finally see this, 100 Celsius for 2 hours. So mine may not have gotten it dry enough. I don't know. Store with a desiccant. That's relatively normal for hydroscopic materials. Oh, this is like if you have an enclosed printer, like something that you put it in one of the enclosures, or it's the Bamboo X1 or something like that. And this is kind of typical for printing PLA materials too. Not for vapor escaping, but for a little bit of cooling. So we're in a wide open printer, so we don't even have a door to close. Avoid long dwell times. So basically, don't let your nozzle sit over the bed or over something for a long period of time at high temperature. So once it's done printing, then it needs to cool down. All right, so we've changed everything except for pressure advance. So let's go back over here. Let's slice this thing. See how long this is. 18 minutes. That's not very long. Let's check out our... Yeah, we're pretty... Okay, I mean, it's not very solid. I would probably want soap to be more solid than that. But that's what it says. So we're going to go with this for now. Let's save that. We'll put it on the desktop. Let's call it soap so I can actually find it. And let's get into Clipper. I assume it has the same address it had last time, but I don't know. One thing now that I have the screen, oh no, you know it doesn't have any right now because I haven't turned on the hotspot. So I got to do that. It looks like we'll just barely have time to get this going. I was also, the other topic I was planning to do today, or well, had in backup if we needed it, is to add the dual Z to this. That doesn't take very long. So I thought we would do that, but I don't think we're going to have time to do that today. It had cooled off, so I've got to reheat it now. I may have to restart it to get it to connect to the or you know, we don't have to. We can just slice it. Oh, there it goes. It just took a while. All right, we're still not hot enough to actually remove our old filament here. So we're over here. We need to get our PLA that was in there out. We're at 150s. While we're in here, we did need to change or check our pressure advance. I'm going to look over in our printer config and see what it's at right now. Extruder. Oh, maybe it's on its own. Oh, maybe we don't have pressure advance set up at all in here, I think. Oh yeah, we didn't set it up. Yeah, so I think we can just add a line to put that 0.05 in there. Let's see, we're not going to have time to actually test it because it takes a while to get it set. Yeah, it goes in the extruder and it just says pressure advance equals. All right, so we can do that real quick. Here you can see what we're doing. So the extruder section right here, we will just add pressure advance equals 0.05. Although I don't know if it's supposed to be an equal sign or, there we go, that looks more correct. Also notice right here, this is true in all your firmware, if you are trying to heat to above to a certain number and it won't go there, you might have a hardware or a firmware limit on how much it's allowed to heat. I'm trying to find our extruder. Unload. Oh, okay. Retract. There we go. It didn't. I was over here. I did the unload on my menu here, but it didn't have an unload routine, so I just did retract. So we've got some filament out now. We can get this out, and we can try to get this in there. So loading flexible stuff can be a pain, although that was super easy. All right, so let's get our temperature extruder up to 240 and see if we can get some filament to come out. I did hear some popping when I inserted the filament, so maybe it's not dry enough. I don't know. I have to restart this in order to get that pressure advance set up. So it's going to restart everything. Okay. I don't think we've tried printing with our new setup here, so we have a lot of new things. We're going to home. Hopefully that works. Let's see if we can get our soap file loaded up over here. That was in, where did that go? Desktop, wasn't it? There it is. It did home this time. Last time it didn't because we had a bunch of filament stuck on the nozzle. Alright, so let's raise our Z-axis. Actually, let's raise it 25. Okay. Now let's extrude a little bit. Let's extrude 25 millimeters just to see what we're going to get. Alright, it's going. That's it's actually like smoking a little bit. It's probably steam. It's very like not consistent. Let's do it again. So it probably does have a lot of moisture in it. Alright, let's try to print. Let's see, where's that at? G-code files. Try to print our soap. I have no idea what's going to happen. Also, I don't know what bed to print on. This is a smooth PEI sheet. Oh, alright, so we did not have any kind of startup routine there. Our nozzle's way too close to the bed. Let's see if we can get our where's the Oh, you know what? I never set the Z offset. That's why. Alright, let's pause that, or cancel that. So I had to have a Z offset of nearly 2 millimeters. Alright, so once we had the Z offset at 2, it actually did start printing. Alright, our bed is not heated at all though. Why is our bed not heated at all? I'm not sure why the bed didn't heat. Let's check Cura. Let's see. Build plate temperatures there is set at 70. Oh, you know what? It's probably not passing the correct temperature. It's probably doing some kind of defaults. Let's see. I don't even see the start G code in here. That's why I didn't do anything to start with. It just started printing right away. So we'll need to fix that in our printer config. But for now, we'll just set it on the dashboard over here. So let's get our bed up to temperature, and let's set our Z offset at 2 millimeters. I think it's just Z offset in the. I think it goes in the extruder. Where does it go? I'm looking for the command, not command, but the parameter you set. Is it just called Z offset or probe offset? I gotta find the actual name for it to know what to put into the configuration file. Sometimes things are set G-code offset. That's not exactly the one I want. Maybe we can just add it in. We'll just go with it. All right. So our bed's 65 degrees. It's supposed to be 75 according to the document. Maybe we'll let it get all the way to 75. Let's home all, because I'm not sure what it's going to do not being homed. Oh, there we go. We can just save. Okay, yes, save. Yes. I might have to, let's see, did it put it in there? Extruder. Yeah. Alright. So now I need to restart our bed and extruder temperatures, because it restarted when I saved the Z offset. But I think we're at 70 degrees on the bed and 230 on the nozzle. Let's go to our file and let's go ahead and start print. Oh, I have to home everything first. Okay. Because it doesn't have a start configuration macro in the, or it doesn't have a start macro in the printer configuration, because we never added one, I have to manually home, manually turn on the extruder, manually turn on the bed, and then it's just going to start printing. So I did that, or actually I'm doing the home right now. And then we will, once it's satisfied with that, we will reprint. And let's see what we're getting. All right, I think our nozzle is a little bit high. Got some burning on that. I don't know if y'all can, I'll see if I can get y'all closer. See over there on the side, you've got some burning. I mean, it's printing and it's sticking down. It's got some retraction issues on the movement travel there. Doesn't smell bad at all. There's definitely some weirdness. It didn't fill in the gap there, so I don't know if our nozzle is too high. It did tell us to have the first layer thicker than the others, but in our flow rate down at like 92%, so it looks like it's under extruding a little bit. But the actual first layer is filling in pretty well. You can definitely see the very little amount of overlap between in this case, the bottom layer and the bottom walls. In Cura, we changed that to what, 10%? It was 30%, and it's just barely hanging on there. So that's what they said. I'm going with their settings, so we will see. It said it was going to take 18 minutes to print. It said maximum flow rate. We didn't actually check that in Cura. We could have. We'll go over here real soon. Remember, you can, in your color scheme, you can change it to flow. And it looks like everything is in the fastest flow rate being maybe this green color, which is, I don't know, 10 millimeters, which it said 12 was the maximum. So, I don't know. We're somewhere in that range. Still printing pretty well. First layer's done. I don't know. I mean, I can hear it. I don't know if y'all can or not, but it's kind of a constant sizzle. And I don't know if that's because I didn't get it dried all the way, or if it's just the way it's going to sound because it's 70% water. I think they said the filaments that they make are 70% water. And so it might just be that that's what this stuff sounds like when it prints. I don't know. I think it's printing pretty well. Is it soap? I don't know. It says that it lathers and everything like actual soap. Oh, I was going to see if this little piece that we cut off of there, if it actually does dissolve. Let's see. I'll go get a cup of water. I don't have one out here. I'll get a cup of water. We'll see what happens. Alright, so we got a can of water here. I'll put you down to it here a little bit. And there's the thing. So it feels kind of soapy. Now this is the unprinted. Actually, no, it kind of is soapish. I don't know if the printed version will be more soap-like or not, but it does have a soap quality, I'll say. Some of these, like, they start dissolving really pretty quickly. This one doesn't seem like it's going to dissolve right away, but it does have soap-like quality. Here we are on our print. It's doing some of the infill now. Again, I don't know what infill means for soap. You would think you'd want a solid bar of soap, but it did say to have a lower infill. Now, just in case you didn't remember, we've got a 0.8 millimeter nozzle in here, so that would certainly make it flow differently than if you're trying to print this on a 0.4 millimeter nozzle. I don't know if it would be better or worse with the 0.4, but this one is a 0.8. And It's a direct drive. So with the flexible filaments like this one, the direct drive is going to give you more control over that flexible filament. If you don't have if you don't have a direct drive setup, you're using a Bowden tube, then try not to do much retraction. And even some of the settings on that it had us change were to change retraction speed in particular, and retraction amount, although we were already on a really low retraction amount. So if you're using a typical Bowden tube, you might have to do some other adjustments. This one's pretty, I mean, we're using, I think we set it at 0.3 millimeters, which you could do 0.3 millimeters on a 0.4 millimeter nozzle. You could do that. This one seems to be printing okay. There's a couple of little spots. When it first started, it burned a little bit over here. And we've got that first layer. I can't tell if it's trying to peel up or if the first layer just didn't get stuck over here. We have not leveled our bed at all. We didn't do a mesh, anything. We don't even have a start G-code set up in our clipper. So a lot of the problems could be just the printer's not set up yet. This is the first print that we've done on it with the new board and clipper new install. But, I mean, in general, looks okay. Oh, it's trying to do some of the lettering now. Alright, so let's see about our film. Oh, so this stuff, it's definitely starting to be more soapy. Like, it definitely feels like a little strand of soap. So, I don't know if it's like useful soap or not, but it definitely feels like soap. Doesn't have any smell necessarily on its own. It did say you could add essential oils to it to give it whatever smell you wanted. But no, it feels soap. Feels like soap. I don't know that it's particularly cheaper, or at all cheaper than just buying a bar of soap. But you can do some interesting things, and you can make it into any shape you want without having to mold it. So it does have some interesting things. The spool is, they said they were hand wound usually, so it's not neat and tight like a machine wound spool, but so far it doesn't seem like it's in any way tangled, so that's good. It does look tangled, but it hasn't acted tangled. I'd like to get our bar of soap finished. Oh, we did have a layer. So this side over here is starting to peel up, and again, I don't think that's the soap's fault. I think that's the fact that we didn't even clean the bed. I just started printing on it. Plus, it's not been leveled at all. But that side is peeling up, and we've got some kind of layer inconsistency right there. I don't know what it caused it, but it's off. It didn't layer shift, it just extruded extra or something. It's printing reasonably fast. I don't know what setting. Let's see, what speed are we going? 50 millimeters a second. So I probably had the print speed in the slicer set to 100 millimeters per second, and it looks like it's averaging in the 50 millimeters per second speed. I'm looking at the dashboard on the screen. Well, and it's also on here too. Let's see. It says there's 7 minutes left. Technically, that'll be past class time, but I'd like to get our little bar of soap without having to stop it early. So if you're watching live, there's no way to speed it up, the 4 of you. But if you're watching it later, you can fast forward to when our soap is done. I do kind of smell it now, but it's not a bad smell. It actually kind of smells like soap or something. Oh, it's starting to come loose. We might have to stop it. Yeah, let's go ahead and stop it. All right, so it was coming loose from the bed. See, it's not even attached. So here's our soap. It is still hot. I don't think the soap's fault for coming loose. I think it's the printer setup fault. But I mean, it's rubbery though. Like, see, I don't know if it's going to dry out later, but that's interesting. It maintains, the filament is rubbery. I assumed that when it printed, it would be more solid, but no, it like rigid, but it's actually rubbery. That's interesting. Let's turn our printer off and get it back out of the way, because that's hot. All right, let's see what happens if we go down here. So yeah, rubbery. It feels a lot like TPU, but it is soapy. Like, I don't know if you would get soap suds. It said you would, but I don't see any. But it's definitely soap, or something very similar to soap. I'm gonna have to wash my hands. And might have to get a paper towel. No, it's definitely soap, but it's rubbery soap, which is unusual. So it feels actually like one of the rubber ducks. It feels that stiffness, so it's relatively stiff, which I assume you could modify with number of walls and infill and all that kind of stuff. Except that once you put it in water, it does start. I guess the surfactant in it starts doing its thing, and it's very soapy. I probably should not leave it in there. I don't know where to put it though. Let me get a paper towel so I can put it on that. So we'll have to dry out our others and see what they end up like. You can start to see where it was starting to print soap. I'll finish tuning the printer so that it actually stands a better chance of printing, and we'll see, on Wednesday, do we still have a bar of soap, or what do we have? I don't know. And we'll see how it goes, and we'll dry out our fire and our ball and our fish bait and see if we can get them to print. The fish bait one specifically said that when it entered water, it started getting softer, so more like a worm would be, or something like that, I assume. So we'll try some of that too. All right, we'll be back Wednesday with new materials. Maybe we'll be able to do some of the annealing talk, at least. I don't know that I've got something that's going to anneal very well though. Maybe we can find a cheap toaster at the thrift store that we can use. You wouldn't want to use your actual food toaster or oven or anything like that, because I think there would be some off-gassing that you probably wouldn't want to later on go eat food that came from there. So I'll see if I can find a cheap toaster somewhere. They're usually at the thrift store. All right, we will be back Wednesday morning with some new filament, and maybe we can light a candle with the fire filament, see how that works. All right, see y'all.